Hello everyone, welcome back to my channel. My name is Dr. Yogita Bish, and in the last video we studied about the basic mole concept, what is mole actually is. So in today's video we will be moving further and we will study what are the different ways of calculating the number of moles. Sometime you will be provided by with mass, sometime you will be provided with number of atoms or number of molecule, and you're supposed to calculate the moles, or maybe sometime the volume will be provided to you. Okay, so there are basically four ways of calculating the number of moles, and with the help of this you will be able to solve any numerical where moles is mentioned. Okay, and if you have not watched the earlier video, I'll provide the link for this earlier video also, so that will give you a rough idea what actually the moles is. Okay, it's better to have a clear idea before you move further and start doing the numerical part. All right, so let's just start with some basic formulas. First we will study the formulas, and then I will explain you how to use these formulas in numerical. Okay, so let's start with the formulas. Okay, so there are basically four major formulas. Number one, when mass in gram is given. Okay, so in that case, number of moles are represented by small n. It will be given mass, and the unit of the given mass will be in gram, divided by atomic mass if we are talking about atoms, or molecular mass if we are talking about the molecule, and the unit would be grams per mole. So here you can see the unit of the number of moles will be, of course, it will be moles. Gram will cancel out. Okay, so this is the first formula, and I'll give you the example side by side. So let's say we have numerical, find number of moles of magnesium in 12 grams of magnesium. Okay, and we have been provided with the atomic mass of magnesium is 24 grams per mole. So it's a straightforward question. So we can just put it in the formula which I have written over here. So the answer would be number of moles is given mass upon atomic mass. So this will be 12. We have to make sure this is in gram. The units are same. It is also in gram per mole. Had it been given in kg, you have to convert it. Okay, so please be careful about the conversions. So this will be 24. So it is 0.5 mole. I'll give you another example. Here we use the atomic mass. Why? Because the magnesium element is being talked about. Here we haven't talked about the molecule. Okay, let's just do another example where we talk about the number of moles of a given molecule. Okay, for example, we'll start with a simple numerical. Find the number of moles of water. Here we have used water molecule, right? Water in 36 gram of water. Okay, so since here we have the molecule, that's why instead of atomic mass we are supposed to use the molecular mass. Okay, so here given mass is 36 gram, and the molecular mass, we all know the molecular mass of water, it is 18. Let me just show you how to calculate this. The atomic mass of hydrogen is 1 multiplied by 2 plus oxygen's atomic mass is 16. So that is why it is 18 gram per mole. So now we have both the values. We can just directly put it in the formula. So the formula is N is given mass divided by molecular mass. So this will be 36 divided by 18. So it will be 2 mole. Okay. So I think this was very easy to understand. Okay. When the given mass is given, you just have to divide it either by the atomic mass or with the molecular mass. Alright. So second formula. Here the second formula is when number of particles or atoms or molecules are given. Okay. So in that case, our formula will be number of particles divided by Avogadro number. That is 6.022 into 10 raised to power 23. I hope you don't find it very difficult to understand. Reason being, in previous video I have already explained that 1 mole is nothing but we are talking about the 6.022 into 10 to the power 23 molecules, atoms or the particle of that particular substance. That's why when the number of particles are given, you just have to divide by Avogadro number to find the number of moles. Okay. So we will do another simple example for this. For example, find the number of moles if a substance contain 1.204 into 10 raised to the power 24 molecules of carbon dioxide. Okay. So the answer would be, here we need not to calculate the molecular weight, while because the number of molecules are given. So we just have to divide by Avogadro number and we will get the number of moles. So it's a straightforward question. So the N will be number of molecules divided by Avogadro number. You must be wondering that our formula is already being written here, why I am writing it again. While it is a good habit to rewrite the formulas. Okay, so when you are going to write these things in exam, make sure that first you write the given values, then the formula, and then put the value, and then show the calculation. Do every step clearly in exam, particularly because each step also contain marks. Half mark for formula, 1 mark for putting the value, right value in the right position, conversions. Everything contains a particular significance or marks. Okay, so from a teacher's perspective, I'm telling you, make sure that you do write each and every step. All right, so this would be 1.204 into 10 raised to the power 24, and Avogadro number we already know, it's 6.022 into 10 raised to the power 23. So this will be, we'll cancel it out, so this will be 2 moles. Okay, so I hope this was also easy to understand. Then formula number 3. Formula number 3, when volume is given under STP condition. This is important. Under STP condition. What is STP? STP is standard temperature, which is 273 Kelvin or 0 degree Celsius, and pressure. So the standard pressure is 1 atmospheric pressure. Okay, so you can use this formula only when the temperature is 273 Kelvin and pressure is 1 atmosphere, or in the formula, in the question itself, STP is mentioned. Okay, so here let's do a numerical also based on this. Okay, so before this, always remember, you have to remember any ideal gas under standard temperature and pressure, that is STP, occupy 22.4 liter of volume. Please remember that. Okay, this is one thing that you need to remember. Another thing, some conversions. Okay, in this particular numerical, conversions are important. So remember, 1 liter is equals to 1000 ml. 1 liter is also equals to 1000 centimeter cube, and 1 liter is also equals to 1 decimeter cube. So when we have to convert ml into liter, you have to divide it by 1000. When you have to convert centimeter cube into liter, you have to just divide by 1000. And if the volume is given in decimeter cube, you are supposed to do nothing while they both are numerically equal. Okay, so you need to remember this. Now let's just write down the formula. So the formula here is given volume of gas in liter. Please remember that normally you will be provided with the volume in centimeter cube or in ml. You have to convert into liter, divided by 22.4 liter. Okay, so this is the formula. Now let's just do some numerical based on this. Okay, find the number of moles of oxygen gas in 44.8 liter at STP. So it's straightforward, reason being you have been provided by volume and also the condition STP. That means we can easily use this formula. So the answer is N is given volume in liter divided by 22.4 liter. We were able to use this formula while STP is given. Please remember that. So this will be 44.8 divided by 22.4, that means 2 mole. Okay, let's do one similar numerical. Find the number of moles of oxygen gas in, let's say, 2240 centimeter cube at STP. Okay, so here we are provided with the volume in centimeter cube. So the volume is 2240 centimeter cube. And how can we convert centimeter cube into liter? We just have to divide by 1000. So this will be 2240 divided by 1000 liter, which is nothing but 2.24 liter. Now we can easily put it in the formula while STP is given. So this would be given volume in liter divided by 22.4. So this will be 2.24 divided by 22.4, which is nothing but 0.1 mole. Okay, so I hope everything is clear till now. So we have covered three formulas. Now the fourth and the last formula is when volume is given but the conditions are not STP. Okay, they are not standard. That means temperature is not 273 Kelvin or and pressure is not equals to 1 atmosphere under this condition. Okay, so under this condition you are supposed to use the ideal gas equation. I hope you do remember what is ideal gas equation. If you don't, I'll make another video for this because it is quite a lengthy topic. So the ideal gas equation says PV is equals to nRT. Okay, P is pressure, V is volume, N is number of moles, R is a gas constant, and T is temperature. Okay, this R itself is very mysterious. Like many students find it difficult to actually use this formula because its value depend upon the unit, which unit of pressure you are using, which unit of volume you are using, temperature you are using. That's why its value changes. Okay, but normally for lower standard the R value will be provided to you. So from this the formula would be PV divided by RT. Okay, so this is the formula you are supposed to use when temperature is not 273 or the pressure is not equals to 1 atmosphere or both the condition are non STP. All right, so let's just do a numerical based on this. Okay, find the number of moles when pressure is 2 atmosphere, volume is 24.6 liter, temperature is 300 Kelvin, and R value will be provided to you. It is 0.0821 liter atmosphere per mole per Kelvin. Okay, so here we need to find the number of moles, but which formula are we going to use? We are going to use this formula while the pressure is not 1 atmosphere and the temperature is also not 273 Kelvin. Okay, since these conditions are not STP, that is why we are going to use this formula. So the answer would be N is equals to 2 multiplied by 24.6 divided by 0.0821 multiplied by 300. Okay, so this will be 1.996, or you can say almost 2 mole. Okay, now another thing that you keep in mind is like which value of R you are supposed to use. Okay, so look at carefully here. Here the volume is in liter, so it's already been provided with liter. Pressure is in atmosphere and temperature is in Kelvin. Okay, so from this value you can consider, okay, this R value we can use as it is. Otherwise, had it been the other way around, for example, volume is being provided in centimeter cube, or maybe temperature in degree Celsius, or maybe pressure in some other unit, then you are supposed to convert them. Okay, so make sure that you compare these units with the other values which are being provided over here. Okay, so these were the simple formulas. Okay, you can also find some complicated formula. Complicated in the sense, here you are provided with the direct values and you were supposed to calculate the number of moles. But you can also get some questions where number of moles you are supposed to calculate indirectly using these four formulas. Okay, so I'll do some numerical based on this. Question is, let's say, find the number of moles, number of molecules, and number of hydrogen atoms in 9 gram of water. Okay, so here, though it's written number of moles, sometimes you will be asked directly find the number of molecules or number of atoms in 9 gram of water. Okay, so sometimes they will not ask you directly to find the number of moles, but we know that, okay, to find the number of molecule, so let's just start with writing things rather than discussing it theoretically. Just write down the values which is being given to us. Number one information, given mass, it is 9 gram. What else is being provided to us? We are calculating it for water, right? So molecular mass we already know, it is 18 gram per mole. Okay, we are supposed to calculate number of moles. Secondly, number of molecules of water, and thirdly, number of atoms of hydrogen. Okay, so we know already the one of the formula, when the given mass is given, molecular mass is given, we can easily find the number of moles. So number of moles is given mass divided by molecular mass. So this would be 9 divided by 18, it is 0.5 mole. Okay, secondly, the number of molecules. So we know another formula for the number of moles when the number of molecules are given, which is N is number of molecules divided by Avogadro number, right? So in this case, number of molecule would be N multiplied by Avogadro number. So this is N is 0.5 multiplied by 6.022 into 10 to the power 23 molecules, which is equals to 3.011 into 10 to the power 23 molecules of water. Okay, you need not to mug up these calculations. Just remember those four formulas that I told you and just write it somewhere in your exam sheet, and then find, okay, this is being provided, what else you can find from this. So things will become easy for you to solve. Okay, and the thirdly, we are supposed to find out the number of atoms. Okay, so in water molecule, we have 2 hydrogen atom. What does it mean? It means one water molecule contain 2 hydrogen atoms, and we are supposed to calculate the total number of hydrogen atom in the given system, right? So here the total number of molecules we have already calculated. So when one molecule contains these many hydrogen atom, then how many atoms will these molecule will contain? So it's just a straightforward unitary method. 3.011 into 10 to the power 23 molecule of water contain 2 into 3.011 into 10 to the power 23 hydrogen atoms, right? So which is nothing but 6.022 into 10 to the power 23 hydrogen atoms. Okay, so here they ask in the question number of moles. That's why we knew the path, like we are supposed to calculate the number of moles. But sometimes this will also happen, they will give you the mass and they will directly ask you find the number of atoms. So you should know, to find the number of atom, first I need to calculate number of moles, then I need to convert into number of molecules, and then find the number of atoms. Okay, and this bigger picture you can easily see by looking at the formulas, the basic 4 formulas. Okay, so I think that's it for today's video. In the next video we will probably solve some other complicated numerical, or maybe we will start with the normality and molarity, because there also we are supposed to calculate the number of moles. Okay, so thank you so much for watching, and if you have any doubt or any kind of comment or any suggestion, you can comment it down below. Okay, thank you so much.